In this section, we're going to look at logical statements and how we can write them symbolically. We're going to start with simple statements. Simple statement is like a simple sentence. You've got to be careful. We're not talking about things like, wow, that's an exclamation. We're not going to talk about those. How are you? That's a question. We're not going to talk about those. We're going to talk about simple statements. Today is Friday. Mary sings well. Statements like that. A subject and a verb, and often a modifier. Okay, we're going to use symbols, which are letters, to represent these simple statements. We may use capital letters or small letters, but the typical letters are P, Q, R, and S, small letters, but we can use any letters. Sometimes we use letters that go along with the statement. We also use a symbol to indicate the negation or the opposite of a statement, and it's a little tilde. So if I put that in front of a letter, that means the opposite of that, or not that. Now in English, we know that we put two sentences together. We have compound sentences, and we're going to look at a couple of kinds of those. Right now we're going to look at the conjunction or the and statements. And we're going to look at the disjunction, which are also called the or statements. So if we want to put two simple sentences together, we do it by putting the and between the letters. If we want to do disjunction, an or statement, we do it by putting the or symbol. If you get these confused, it might be easy to remember the and statement kind of looks like a capital A without the bar across it. So you start to write a capital A, and that's the and statement. Remember, when you make an and statement, for both parts to be true, for the entire thing to be true, both parts have to be true. So to say, for example, Washington was our first president and Lincoln was our second president, would not be true because both parts are not true. And both parts need to be true for an and statement to be true. That would be true if it was a disjunction, an or statement. Washington was our first president, or Lincoln was our second president. That's true because one of them is true. When we talk about or, we can mean either one or the other, or both. In order to get into the play, you either need to have a ticket or know the manager. It's possible you have a ticket and you know the manager, but that still satisfies the or. Okay, let's look at some examples where we can take a simple statements and convert them. I'm going to start with these simple statements. It is raining will be my P. Pat has an umbrella will be my Q. And Pat gets wet will be my R. So what if I want to say, it is not raining? Well, P is it is raining. So if I want to negate that and say it is not raining, I will put a little tilde in front. Not P. It is not raining. Okay, let's make a conjunction. It is raining and Pat gets wet. So I'm going to look at first statement. It is raining. That's P. Pat gets wet. That's R. So symbolically, my sentence is P and R. It is raining and Pat gets wet. So I've written the whole sentence in the symbolic form, much shorter. Okay, let's try this one. It is not raining, or Pat gets wet. Okay, remember, not, we have to do the opposite of it is raining. So, not P, it is not raining, or Pat gets wet. So that gives us the R. But you try one. Pat has an umbrella. And Pat does not get wet. Pause this, think about it. Write your answer down, then start up and see if you got the same answer as me. Okay, Pat has an umbrella, so that's Q. And does not get wet, so that's Q and not R. Now we have another symbol that we call either implication or conditional. If we have two arrows on it, we'll call it biconditional. It's an arrow with a biconditional. Bi, remember, means two. Is the if something, then something. The biconditional is if something, then something, and it's vice versa. So we're going in the other direction also. So here I say, if I study, then I do well. It's not the same thing as saying, if I do well, then I study. If I want to say both at the same time, I use the biconditional, and I usually say something, if and only if something else. Again, in English, we'll often say, if something, then something, blah, 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 and vice versa. That's the same thing as the if and only if. So let's bring back our little statements here and try some examples using them. If Pat does not have an umbrella, then Pat gets wet. Okay. So if Pat does not have an umbrella, Pat has an umbrella's Q. If we want to say he does not, and that's not Q, then Pat gets wet. That implies Pat gets wet. So that's the conditional statement. Okay. What about Pat gets wet if and only if it is raining? So here we're going in both directions. If Pat gets wet, then it's raining, and also at the same time, if it's raining, then Pat gets wet. So Pat gets wet or, if and only if, it's raining is P. Now, what if we want to put more than two of these together? Then we'll have several together. And we can tell how they are grouped by the commas. So let's take the statement, it is raining, and Pat has an umbrella, comma, or Pat gets wet. And then let's do, it is raining, comma, and Pat has, left out the word and, an umbrella, or Pat gets wet. Okay. And this one, the comma, groups these two things together. So it is raining, it's P, and Pat has an umbrella, is Q, or Pat gets wet. So we are grouping the two together that are on the same side of the comma. Here we're putting Pat has an umbrella or Pat gets wet together. So it is raining, and then these two go together. Pat has an umbrella, or Pat gets wet. These two statements are not saying the first thing, are not saying the same thing. In the first one, we're saying there's two possibilities. One of them, it's raining and Pat has an umbrella. The other one is that Pat gets wet. In the second statement, we're saying two things, and we're saying both of them. One of the things we're saying, it is raining. The other thing we're saying is that either Pat has an umbrella or Pat gets wet. So we're saying two different things, and we know which we're saying by the parsing or the commas in the English statement. Now, if we were going the other way, we would know where to put the comma based on where the parentheses are. And just like in algebra, we have an order of operations. You know that when you do this problem, you know automatically you are supposed to do the multiplication first. And that's the order of operations. Multiplication comes before addition. But what kind of problem is this? This really has a parenthesis around here, and we call this an addition problem. Just happens that we're adding two things, and one of them is a little bit complicated. It's a 3 times 4. But what if we wanted to do it this way? We put the 2 plus 3 in parentheses. If we want to do it that way, we're forced to put the parentheses, because without them we assume the first way, because of our understood, agreed upon order of operations. In this one, though, if I have 2 plus 3 times 4, this is a multiplication problem. Okay, well, we're going to do the same thing with the logic. We have what we call the order of precedence, which is kind of the reverse of the order of operations. Now, they're not as well defined as the ones on the arithmetic, because the order of operations, we're going to do the nots first, unless they're parentheses, and the ands and the ors. We don't have any rule like left to right. So because we don't have that rule, it can be ambiguous. So if we have both of these, we need parentheses to avoid it. Otherwise, you'll have ambiguity. In other words, not knowing which one. Okay, so the order of operations, like the example at the top here, it's not ambiguous. We know the multiplication is done first because we have that rule. Here, if we have and or together, we don't know which is first. Okay, And same with the biconditional and the conditional. They're last, but we don't have a rule, so we need parentheses to indicate which. So precedence goes in the opposite direction. The conditional and the biconditional are first, the and the or second, and the not is last. So that means if you saw these three things in a statement, you would work it out, figure out the truth value of it, starting with the not, but you would call it the type of question it is going by the top. Just like in this problem, we would start with a multiplication. We'd call this an addition problem. Okay. Let's look at an example of this, again using our same little statements here. Oops. I'll make sure you can see them. Move them over here so we can see them more clearly. Okay, so let's suppose we want to say, if it is raining, and Pat does not have an umbrella, then Pat gets wet. Okay. So, if it is raining, Pat does not have an umbrella, then Pat gets wet. We're doing this part first because the order of precedence tells us. And we have only one thing from each level. If we had more than one of each thing, it would be ambiguous. It would be hard to tell. Sometimes impossible to tell. But in this case, we only have one not, one and one implication. So we know that the parentheses go around the P and not Q. At this point, this is probably new to most all of you, so you would probably want to put those parentheses in to make it clear. Now in the next section where we do tables, you definitely want to put those parentheses in to make it clear what you're going to do first. So P and not Q implies R, or if P and not Q, then R. If it is raining and Pat does not have an umbrella. So if it is raining and Pat does not have an umbrella, then Pat gets wet. Okay, just to maybe demonstrate this a little bit more, let's take a very complicated looking statement. Not P and Q implies R or S. The one that takes precedent is the implication. So written as it is, it's the same as putting parentheses around everything in front of the if-then, or the conditional arrow, and one after it. So this kind of statement is an implication or a conditional. Okay. Let's write the same letters with the parentheses in a different place. Let's suppose we put the parentheses around the beginning. And around the implication. So now I'm saying this thing and this thing. Here I'm saying if this complicated thing, then this complicated thing. So where I'm putting the parentheses makes a difference. This one's a conjunction. Now order of operations would tell me in this one, work inside the parentheses first, do the not first and then the and. Then work inside this parentheses, and finally when I have these two answers, I will do the conditional or the if-then. This one's telling me work inside the parentheses, so do the not first. Over here, Q implies R or S. I want to do the R or S first, so put those parentheses in. Put them in red, because technically they're optional. So I do those first, because order of operations says I do OR before the implication. So I do these, then I do the implication, because these are in parentheses, and lastly, I would do the AND. Now let's take those same letters, and this time let's put parentheses around these. And the order of operations would tell us to do inside the parentheses first. So I would do the not P first. Maybe I wouldn't write parentheses around there. That just maybe makes it look a little too confusing. Put it like that. So inside I would do what's inside this big parenthesis first, which inside of their order of operations would tell me that I need to do this part first, because this inside part's an implication. So in here I would do the not, and then the and then I would move out, and then I would do the whole thing. But I have this big piece, or this little teeny piece, so this entire thing is a disjunction. Okay, let's write it one more way. And this time, let's write parentheses this way. So this would tell me I would need to do what's inside of these parentheses first. The one that takes precedence is the implication. So the and the or would be in parentheses. So I would have to work this and out, and then work this or out, then work the implication out, and finally take its opposite. So this is a negation. And a negation only takes one value, sort of like we were talking about the numbers, like a square root. Adding, we need two things to add. Multiplying, we need two numbers to multiply. Take a square root, we only need one number. So for this section of homework 5, you will be writing in the symbols to represent the sentences, or you'll be picking from a list, a multiple choice list, the sentence that matches up with the symbols that are given. In the next section, we will actually start evaluating these. Remember, the word evaluate means to substitute or plug in values. The values we'll be plugging in are true and false, because we can make statements that are true or false. Some statements you know are true, some you know are false, some you do not know. If I say Washington was our first president, you know that's a true statement. If I say Lincoln was our second president, you know that is a false statement. If I say your instructor, Catherine, has a pet cat, well, that's either true or false, unless you happen to know me or be at my house and have seen whether I have a cat or not. You don't know whether it's true or false. It is true or false, you just don't happen to know. So we're going to look at a table with several letters, assuming we don't know any of them. So we've got to think of all the possibilities and figure out the truth or falseness of the individual statements.